Before we continue, I first want to thank our sponsor, ClearVector. ClearVector helps you detect, investigate, and stop threats at runtime in your AWS environment. Our real-time identity-driven approach enables you to quickly figure out who did it and take action. Get started today with a free real-time risk assessment of your AWS environment. All right, our next talk for the afternoon is A Year of No, Building Organizational IAM Guardrail Policies That Work with Noam Dahan. Thank you.
Thank you, Joel. Thanks, everyone. Always fun to be here at Forward CloudSec, and always tricky, especially when you're, sorry, I'm plugging this in, especially when you're giving a talk like this, because, you know, service control policies and guardrails are reasonably well-trodden ground for this audience and for this conference, but I think we have some interesting angles both on multi-cloud, how, why, and a little bit into the tactics of actual execution. This is the talk after lunch, so I wasn't sure like how I was gonna, I don't know, like handle the situation. So I hope everybody's awake and up and had a good lunch and do not need to be amused with other things. What's on the agenda today? So why guardrails? Why do they exist? Why do we do them? Some strategy into how we build them, then a little bit into the internals of org policies in AWS, GCP, Azure, the different providers, and then a tactical approach on how to construct and test them. So why do we have guardrails? And the first reason is, so prima facie, guardrails are almost by definition redundant, right? If the only thing that is preventing something from happening or from a permission from being an effective permission is an SCP, then in a way we've done something wrong because guardrails are always by definition a defense in depth. So their redundancy doesn't mean they're not important. The reasons we need them is first because we always assume, I'm not even gonna, is because we always need to assume that the perimeter will be breached. This is like for the people with a military background, a very cringe moment perhaps, but we do need to assume that attackers will breach our perimeters. We can't take the old approach, not that it was even that correct then, of protecting the perimeter and assuming nothing will happen inside. And so we have to take defense in depth. The reason why they work and they're effective is that attackers always operate in a limited information environment, whether that's an opportunistic attacker or a high value attacker with a lot of foreknowledge. The third advantage that they leverage is that you know your environment significantly better than your attackers, so you know what assets you need to protect and what assets you don't want to expose. And the last reason is because they're just common mistakes that are very costly and you want to prevent, whether that's actual insider threat or just like a confused employee doing something wrong. And there are a lot of, one purple link. There are a lot of really great policies there online, which would perhaps mean this talk isn't like critical, which is, you know, AWS just released an incredible samples repo divided into like sections. I'm gonna show a screenshot from it. There's also community sourced ones. There's also the Azure and the GCP policies. Like the new AWS repo looks like this. It has all these, I know the text is really small. It has all these different sections. Deny member accounts from leaving the organization, enforce data parameters so that you can't access resources outside the VPC. A lot of really, really handy ones. And if someone didn't get a chance to get a screenshot, to get a shot of this, the slides will be up, but this is a good one. All of these are remarkably good. So at that point, like I could end my talk, right? And like give you a picture of my cat and my contact links and be done with it. But the problem with this approach, perhaps, is that it is very associative. It's about what we just came up with, what we just thought about. Okay, so an attacker might try closing CloudTrail. Okay, so I'm gonna prevent the attacker from closing CloudTrail. Okay, an attacker might wanna access resources outside the VPC. I'm gonna prevent that. But we want a more methodical approach, a more evidence-based approach, a more testable approach, and an approach that we can tailor to our specific needs and our specific environments. And for that, we need to deal with two types of threats, right? The more opportunistic attacker. This is the people that crop up when somebody commits a user access key to GitHub. The people who will crop up are opportunistic attackers. They have been stranded in the wild. They don't necessarily know what's going on, but they're here to cause all the trouble they can. And the persistent attacker, perhaps with foreknowledge, perhaps with intelligence, and perhaps just with a willingness to be a little more careful and a little more purposeful. This can also be a way to view like the two different types of insider threat, right? An insider threat that is malicious and is trying to cause damage versus a confused employee doing incorrect things, which are coincidentally like the two problems that DLPs have to deal with as well. And what's the process, therefore, that we suggest? And if this was a 40-minute talk, we might dive into each and every single part of that process, but it isn't. So instead, what we're going to do is explain, leave a lot of it up as an exercise, and then dive into points which I think are particularly interesting in the 13 minutes we have left. So the first part is to identify a weakness or a threat or a TTP, a technique that we're defending against. The second step is to construct a policy that's capable of preventing it and implementing it. The third part is to test it against our logs, before implementation, to know what we're going to be blocking that is already happening, perhaps intentionally, or if unintentionally, perhaps you just like caught something, which would be great. Then implement it and detect violations, because the interesting thing is that every guardrail is also a really good detection, right? You've obviously set something up as a guardrail because you think this isn't something that's even in the realm of, not happening right now, but reasonably could be happening legitimately very soon. So build a detection and close exposed weaknesses, which is why we're diving into internals to understand how an attacker can bypass a guardrail or what workarounds exist. So internals. Okay, so generally guardrails limit service accesses and actions, and by definition, they're quite coarse. They're not like super fine-grained instruments just surgically tuned to their purpose. In AWS, we have service control policies that they follow either an allow list or a deny list strategy. I will say the deny list strategy is significantly more common, not like allow listing the only actions that can be executed, but just having denies for things that you want never to happen. And they work by an inheritance decision rule, which is if we have the organization root, then every policy, all the policies that are applied to the root and all the policies that are applied to the OU and all the policies that apply to the nested OUs and all the policies that apply to the member account all have to allow or rather not deny the policy. So you have to be allowed at every single level if we're talking about an allow list strategy, which is why coincidentally, if you've noted, every single one of your organizational units has the AWS full access policy attached to it. Otherwise, it wouldn't work. And they need to do that. The thing about them, and this is the main bypass for how I would bypass SCPs in a red team engagement, or perhaps, not a red team engagement, is that they do not apply in the management account. And the annoying thing about AWS, or I shouldn't say annoying, but the particular thing about AWS is that the management account isn't here. This is just the mathematical root of the tree, but it's not a real thing. It's just an object that exists. It's not an actual account. The management account is just like this one account that we made queen, right? We declared that this is the management account, and you can't tell this one what to do. And so the best practice recommendation is to have a management account that is only the management account. There is nothing there except being the management account. There are no workloads there. There is nothing going through there. Unfortunately, the way companies are built is not that someone starts the first account of the company and says, this is an account where I'm not going to do anything. And so oftentimes that account does inherit something. It's a logging account. It's a login account. It's an actual, God forbid, production account, but it's going to be an account that does something, which means that it holds relations to other accounts, which means you can try to get into it and bypass every single SCPs, because again, SCPs do not apply in the management account. There's also all of IAM's limits as a language, that it's text-based, it's unscoped, like you can't say a policy applies to this resource group of resources, unlike GCP or Azure. And it's kind of hard to build exemptions, but given time, you can ask me about that later. GCP. So GCP has these 4 main mechanisms. I'm going to dive into them: organization policies, VPC service controls, access context manager, and new deny policies. I think about a year old. So organizational policies are the primary instrument here. You apply them at the level of the organization. So it can be an organizational unit, it can be a project, it can be just the entire account, and they apply there. They are, similarly to Azure policies that we're going to see, kind of a mix of authorization policies and remediation policies and detection policies. They kind of do all that in one big mix. But what we're discussing within the scope of this talk is their use as authorization policies, i.e. deny stuff, right? So they can be used to deny a lot of stuff. I don't remember if I have, so I have a few examples here in the slide. They are just the lexicographically, they're the examples that start with A, but there are a lot of them. So basically, you can say that you're not allowing cloud function generations, or you're only allowing cloud function generations under a certain list, or you're not allowing public instances, or you are allowing them under a certain list. There are 2 types. There are Boolean constraints and list constraints. List constraints say you can only have one of these values. Boolean constraints say you can or can't do this. So they're quite handy, but they are limited in specificity. Like, this is the prefab policy warehouse, and this is what you get. And the capability of building custom ones is perhaps somewhat limited. So they're useful, but A, you're a little bit drowning in them. There are a lot of them, and B, they're a little non-specific. VPC service controls are basically the main data parameter control for GCP. They mean that clients within a parameter, so the main thing that they do is that clients within the parameter don't have access to resources outside the parameter, and vice versa. And they control ingress and egress roles for data exchange, and you can actually have like context-aware access controls. So that's like condition keys in AWS. You can ask certain questions about the context. What I think is really cool about GCP VPC service controls, and I would like to see elsewhere, and I also I put this in the tactical part of implementation as well, is that they do have a dry run mode. And I think it's incredibly cool that you can see already in your environment how a certain organizational control is applied, and then gradually make decisions to narrow more and more your organizational controls. I think it's interesting both if you're using GCP, which is, really cool for you, but also to learn from in how we use AWS and how we use Azure and how we use other spaces, because I think Google's done really well with this one in particular. Access Context Manager, I'm not going to talk a lot about because of the limits of time. Sorry. Okay. Sorry. I just do want this to work. But basically, it limits access to scopes by certain conditions: IP, geolocation, device. So it looks kind of like this, and you can say, okay, only certain IP subnetworks, only certain geographic locations. If you want to pay more, you can sort of have a device manager that filters by device, or write CEL. CEL is Common Expression Language. It's basically like fancy regex meets condition keys type thing for writing Boolean expressions and evaluating them, and it's reasonably cool. And GCP deny policies, which have sort of been, it almost feels like a little like a soft launch in the sense that this is a good idea. This is like deny SCPs for Google. However, they're not supported in the console. You can only have, I think, 5. And they behave in a similar way to AWS. The thing they do slightly better or slightly more intuitively than AWS is handling exceptions, because like you have an all users principle, and that means all users except the ones already specifically mentioned, which for those of you using AWS is a construct you might have found yourself sorely missing in the past, because it's just really hard to say not this and not this. And if you put 2 nots, then they cover each other, right? If it's everybody in this room not named Igal and everybody in this room not named Joel, it's everybody in this room because they mutually cover each other. So they handle it a little better. Azure policies are both preventative and retroactive, so they're again a mix. And it can also be combined with scope level IAM policies. Deny assignments only apply under something which I don't have time to talk about, which is Azure Blueprints. But it should be said that Azure has less powerful tools for this. Not because Azure is bad, right? We kind of, I think we kind of say sometimes mean things about Azure just because it's a little different than the other cloud providers. And that was not originally intended as a joke, but I think Azure just works with a PIM identity-based approach. The approach is significantly more based around controlling who is in the environment rather than exactly controlling what they can or can't do in the environment. These are some Azure policies. So, here you can only allow certain VM SKUs, for example, and that's a deny policy. It operates on the level of authorization. It will prevent you from doing that. The rest of them you can see audit policies or disable if you do it or things like that. So tactics and execution. So back to this slide, remember, identify, construct, test, detect, and close weak points. What weak points? Things like the workarounds we just discussed. So with identify, you can sort of go 3 ways about this. You can be attacker driven, which is I ask myself, what would an attacker do? Or what are attackers doing in the wild? So that can be guided by something like MITRE or CSET, can be guided by your research, can be guided by common sense of saying like, okay, if I were an attacker, this is where I would want to get in the environment. This is what I would want to do in the environment. Can be defender driven, like saying these are my crown jewels. This is my DynamoDB that I don't want anyone to touch. Or these are my key parameters. This is the VPC that I don't want anyone getting into. They can be standards driven and work around frameworks and recommendations. So let's give one like attacker driven example of how to do it. And so this is the MITRE matrix, right? The MITRE cloud matrix. Also, I think a very interesting birds of a feather session coming up at 5 p.m. About it. And it has a lot of things. So let's look at one tactic like impair defenses, and then inside, we have a lot of tactics here. So one of them is disable cloud logs. And if we look into it, we see that for AWS, we have stop logging and delete trail. For Google, we have update sync. And for Azure, we have monitor diagnostic setting delete. So in AWS, for example, what we would do, and this is a policy that many of you have in your accounts already because Control Tower deploys it, is set up a policy like this, right? Except you have to, again, the textual limits of the SCP, you have to fill these out manually. And if it's hard to read text from the back, this is like the operative part, right? These are the API actions that we're preventing. And I think the interesting part of it is not that we ended up with this policy, right? Because a lot of people in this audience already have this policy in all their accounts. But it's, let's look at everywhere else in the MITRE matrix and figure out non-trivial policies that apply to our organizations in ways that are driven by attacker behavior. So a methodical more evidence-based approach to this whole problem. And intentionally, I'm not here to give a handful of SCPs because they're all in slide 5 that I showed you before. This is more about how we approach this. As far as testing versus logs, so testing versus logs, I think comes at 2 stations, one before deploying. This is like a SQL query that you can run in Athena, just like look for access denied where the error messages has the words service control. Conveniently for very many services, AWS has made error messages more descriptive of the reason of the error message. So you can use that to see detections of where people or attackers are banging up against your service control policy, and then filter from that and see suspicious behavior. Before implementing a policy, you want to build a policy like we would build a policy that has put event selectors and CloudTrail stop logging and CloudTrail delete trail and CloudTrail update trail, and see who is doing that in our entire organization. Are these legitimate uses? And if they are, we have to put these principles in the exemption list so we don't break the organization. So we use logs to build SCPs twice. First, before constructing and implementing them to create a de facto dry run. And secondly, after implementing it, to create what can be a very effective detection. Because if we've built this by thinking about the way attackers are behaving, by thinking about what are our crown jewels, then someone banging up against the walls of our SCPs should be something that raises the alarms. We have a similar condition key for Azure, for example. And with that, my time is out. But if there are any questions.
Thank you, Noam. For those of you watching on the live stream, there's a Slack thread in the Forward CloudSec channel. If you have questions, please post them there and I'll monitor them. But just sort of to get this kind of kicked off, how do you, as you sort of build these policies out, how do you make sure you're able to stay agile enough to adapt to changing business needs so that you stay relevant so that the business doesn't just try to work around you?
So that has a lot to do with what was in the slide about the R course, and that is by design. So guardrails in general should be course limitations, which violating is a significant enough security engineering change to warrant a discussion anyway. The fact that I'm creating friction because someone wants to publicly expose a new VPC, or if we are an organization that only publicly exposes one VPC, right? If we're the organization that every week exposes a new VPC, we wouldn't be setting up that guardrail. That warrants a serious discussion, and the fact that it causes friction for that, if we've selected our guardrails appropriately, should be a good thing. Same goes for if we're the type of organization that doesn't allow a creation of IAM users. So someone like Dev could be cropping up saying, I want an IAM user, I can't resolve this. It's good that this friction is happening. We don't need, I know like you can't later say, why are you causing friction in an organization where, well, Noam in Forward CloudSec said it's okay, right? This isn't like helping anyone in a way, but philosophically it's the right thing, and security-wise it's the right thing.
Thank you. And then when you talked about like sources of policies, you mentioned attacker-driven, defender-driven, and standards-driven. I sort of look at that and I kind of get overwhelmed trying to think about like, how do I not just drown in all of these sources of events? How do you like take that and make that practical and useful and not something that becomes a checklist and that you can keep alive and up to date?
So that's a very good question, and to be honest, it is just a foundational problem of security, right? Security is overwhelming, and you are overwhelmed with data. I don't think it is slide 5 that this approach is a bad place to start. It does collate a lot of good information, but I think we are interested in creating within our organizations processes which say, no, for us, the lambdas are a big deal. For us, the publicly exposed lambdas are a huge deal. Or for us, we have a certain security parameter that we're very strict around keeping. Or if you're the type of organization that has really great egress controls, then I don't know if one of these policies is going to apply to your business needs. You need to figure out what are your red lines that you want to keep.
All right, well, thank you very much.
Thank you.